This is proof that the Goldbach conjecture is true. Every even number within infinity is the sum of two primes.
In this problem, I applied the principle of going against the obvious as seen in the film Ready Player One. It looks like everyone for 300 years has pursued what seems must be the only way to solve the Goldbach conjecture, which I did for months also, by trying to map the density and gaps between primes to prove where primes must sum to an even number x. However, after months of studying, meditating and working out in paper, I realised that is probably impossible. But I realised what we can do is map where all odd composite numbers are, eliminate those and the odd number which they pair with and sum to make x. Then all that are left must be prime pairs which sum to x. So just because the solution looks easy now that I have solved it, thinking backwards to break free of a belief which seems must be true and to find what is not obvious is anything but easy. And here is the absolute mathematical proof with examples.
Every odd number under half of x pairs with an odd number above half of x to sum to x. An odd number never pairs with an even number, so we can eliminate all non-prime pairs using the sieve. So by doubling the primary sieve to remove all multiples of primes less than the square root of x, which is x divided by two odd numbers, less a third, less a fifth of the remainder, less a seventh of the remainder, less 1/11th of the remainder, etc. Remove double the amount of odd numbers to remove all multiples of primes less than the square root of x and the odd number which they pair with and sum to make x, which is x divided by two odd numbers less 2/3, less 2/5 of the remainder, less 2/7 of the remainder, less 2/11th of the remainder, etc. So the only odd numbers remaining must be primes and in pairs of locations which sum to x.
The only way we could have an exception is if the fractional deductions of composite numbers made from primes less than the square root of x catch up in number and eliminate all primes added since the previous highest value of a prime less than the square root of x, ph. This, however, is impossible because the extra fractional deductions decrease exponentially in their ability to remove primes, while the number of primes grows incrementally, only halving in primes per integers with every doubling of integers. For example, at only the 10,000th prime, which is 104,729 squared plus 1, we get x is 10,968,163,441. There are 5.5 billion odd numbers, and here the sieve eliminates 99.915219.285% of all odd numbers, including primes. However, that still leaves a whopping 26.5 million primes, giving 23.25 million prime pairs, and in mathematical terms, that's a tiny number.
So because the only odd numbers left after such fractional deductions must be primes, and because they must be in locations where they pair and sum to x, and because the number of primes less than the square root of x grows slower in proportion to the number of new primes, it means the fractional deductions of multiples of primes less than the square root of x is always outpaced by the number of new primes, as the value of x increases, always ensuring there will be more prime pairs as the value of x increases towards infinity. So the Goldbach conjecture is definitely true. For anyone not understanding immediately and wanting to see working examples, I provide 3 examples at the end of this video.
I used a similar Ready Player One type method of removing all false beliefs to prove a loop other than 1421 is impossible in the 3x plus 1 problem, the Goldbach's conjecture, and to solve the double slit experiment based on experimental evidence and common sense, which changes everything about our understanding of the subatomic world and which the evidence shows will revolutionise physics and technology when someone runs the new experiments which I propose. I'll try and upload as many of those as possible as soon as possible.
I also proved a loop impossible in the Goldbach's conjecture, the 3x plus 1 problem, and solved many more problems in maths and physics. But with no money or contacts in academic institutions, I've been unable to get peer review. So please share my work, please like, subscribe and click the bell to be alerted to see upcoming videos which I'm already working on, and there's lots more coming. Thanks for watching, and may the force of love be with you.